In this part, we will discuss about the challenges which are facing in solid-state batteries. The first one is interface compatibility, and the second one is cost consideration. The third one is limited ion transport kinetics, and the fourth and the most important one is scalability and commercialization. What is interface compatibility? This is the most important and the biggest challenge in solid state batteries. The interface between solid state electrolytes and electrode material can pose challenges. Issues such as interfacial reactions. What is interfacial reactions? Basically, interfacial reactions refers to a chemical reaction that occurs at interfaces between different components of a battery. They can be electrolyte to electrode interface, electrode to electrolyte interface, as well as interfacial resistance, which also as a results as the biggest hinder in solid state batteries and form resistive layers that can hinder ion transport and degrade battery performance over time. The second one is cost consideration. Solid state electrolytes, especially those based on the advanced materials like garnet electrolyte. Basically, garnet electrolyte is more expensive as compared to other electrolytes. So, by using garnet electrolyte, there is a high cost, which is also a biggest hinder in its scaling production. Scaling up production, reducing manufacture costs are important factors to consider for widespread adoption. The third one is limited ion transport kinetics. While solid state electrolytes can offer high ionic conductivity, they may still have lower conductivity compared to liquid electrolytes. This can result in higher resistance and limit the rate of charging and discharging, affecting the power capability of the battery. The fourth one is scalability and commercialization. To produce any chemical in the industry at a very high rate, basically its cost should be very less. There is also in solid state batteries, the chemicals, the products which are used in it are very expensive, which results in its low scale production. Solid state electrolyte technology are still in the early ages of development and faces challenges in terms of scalability, manufacturability, and integration into existing battery manufacturing processes. Achieving large-scale production and commercial viability is a significant hurdle that needs to be overcome. Recent development in solid-state batteries. Lithium-ion batteries have attracted worldwide research interest due to their high energy density and long life cycle. Solid-state battery improve the safety of conventional liquid-based electrolytes by replacing the flammable organic materials with the solid electrolytes. This also increases safety and also increases its lifespan as well. According to the Frontiers Review article, that they are using hybrid solid electrolyte demonstrate great promise to achieve high conductivity, reduce interfacial resistance, which is also a biggest hinder in solid state batteries. The present review provides insights into HSC development to allow a more efficient and target-oriented future on achieving high performance in solid state batteries. Now we will discuss about solid state cathodes, that what type of cathodes are used in solid state batteries. Basically, there are many cathodes which can be used in solid state batteries, but we will discuss the most common one. The most common one is lithium carbon oxide. Lithium carbon monoxide is a well-known cathode material while widely used in conventional lithium-ion batteries. It has a high energy density and good cycling stability. It is also compatible with a certain solid electrolyte system. Here is the structure of this. Now we will discuss about another electrolyte cathode, which is lithium iron phosphate. Lithium iron phosphate is another popular cathode material. Lithium iron phosphate has been explored as a potential cathode material for solid state batteries. It has the speciality because of good stability in contrast with the solid electrolytes. In any solid state battery, we should have a good stable product, and lithium iron phosphate have a very good stability, so it is also very widely used in solid state batteries. Lithium iron phosphate chemistry is considered environmental friendly compared to some other lithium ion batteries that contain more toxic or rare materials. It does not contain heavy metals like cobalt. Basically, to use any material which is toxic for our environment is not good. So lithium iron phosphate is environmental friendly, so this type of material is widely used because of this reason. Sulfur based cathodes. Sulfur based cathodes are also used in solid state batteries. Why they are mostly used? What are their specialty? Sulfur is a highly favorite to use as an cathode because it has highly capacity as compared to the other lithium cobalt oxide. The high capacity offers the potential for lithium sulfide batteries to store more energy per unit weight, resulting in higher energy density batteries. Here are some advantages of using cathode materials. First one is high energy density, second one is long cycle life, and the third one is wide operating temperature range. First one is high energy density. Cathode materials in solid state electrolytes can offer high energy density, allowing for the storage of a large amount of energy in compact battery systems. The second one is long cycle life. Cathode materials in solid electrolytes can exhibit excellent cycling stability, enabling the battery to undergo a higher number of charge and discharging cycles. The third one is wide operating temperature range. Solid state electrolyte, when coupled with appropriate cathode materials, can offer a broader operating temperature range compared to a liquid electrolyte. This allows batteries to function effectively in extreme temperature conditions. But in existing batteries, there is no range of temperature and there was only a room temperature. What are the challenges by using cathode? Limited material selection. We have limited cathodes. The second one is cost consideration. Some cathodes are very expensive, which increase the overall cost of solid state batteries. The third one is manufacturing complexity. Precise manufacturing processes are required to ensure proper formation of interfaces and to achieve for optimal electrode to electrolyte contact, which increase for production cost. Here are some solid state anodes. The first one is lithium metal, which is a very and most commonly used anode. The second one is silicon, and the third one is lithium titanate. First one is lithium metal. It is the most favorite cathode. Lithium metal is a promising anode material for solid state battery due to its high theoretical capacity and low potential. It offers the potential for higher energy density and improved performance as well. The second one is silicon. Why silicon is most favorite? Because it has a because it is a very high capacity anode that can deliver significantly high energy density compared to the graphite. The third one is lithium titanate. Lithium titanate, often abbreviated as LTO, is an anode material known for its exceptionally cycling stability, safety, and long cycle life. Here are the advantages of anode materials. Anode materials play a critical role in the performance of solid state batteries. By using advanced anode materials such as silicon, lithium metal, lithium titanium oxide, we can achieve significant improvements in energy density, cycle life, safety, and charging times, which is the most important things of the battery. Anode materials can enable faster charging because the reason is this: they can facilitate the movement of lithium ions more quickly between the anode and the cathode. Challenges which are faced by which are faced in solid state batteries by using anode. First one is dendrite formation, which is the biggest challenge. Basically, dendrites are tiny needle-like structures that can form on the surface of the anode and penetrate through the electrolyte, causing a short circuit. The second one is interface compatibility. Another challenge with use anode in solid-state batteries is ensuring compatibility between the anode and the electrolyte. The anode and the electrolyte must have similar chemical and physical properties. Uh, by If we do not use the same similar physical and chemical properties of the anode and the electrolyte, there is interfacial resistance, which is the biggest hinder. The third one is fabrication difficulty. Fabricating anodes for solid state batteries is also a challenge due to the difficulty of producing high quality, defect free anodes. Anodes must be fabricated using complex processes such as sintering, which can result in defects that affect the performance of the battery.